In this video, I'm going to talk about optimization. In particular, I want to optimize or maximize the area or volume of a geometric figure that is inscribed in one of our conic sections. But in real life, what things that might be optimized would be, for example, in business, you would want to maximize your profit and minimize your costs. Or in transportation, you might want to maximize the amount of cargo that you can transport and minimize the cost of fuel and the number of miles traveled. So these kinds of problems are investigated all the time in real life and are one of the types of ways you can apply math in a career. But let's go back to our more simple example of this rectangle that is inscribed in an ellipse. By inscribed, I mean that every vertex of the rectangle is a point on the ellipse. So we are going to put a hypothetical point, xy, somewhere in quadrant 1 here, and this is going to be the corner of the rectangle, and it's also a point on the ellipse. And as this point would move, if I were to move this point closer to the x-axis here, notice how the shape of the rectangle changes. So x could be, if x were 0, there would be no rectangle at all. If x were 5, there would be no rectangle at all. But if x is somewhere between 0 and 5 in this ellipse, then I'm going to get a rectangle that has a maximum area. So how do we do that? Let's first of all start by drawing the ellipse that we are investigating. So a rectangle is centered at the origin and is inscribed in this ellipse, which is also centered at the origin. This ellipse goes 5 in the x direction and 5 in the y direction, or sorry, 5 in the positive x direction and the negative x direction, and 3 in the y direction. So I'm going to kind of sketch my ellipse here. And then I'm going to inscribe a rectangle. Now, this rectangle isn't in, oh, that was kind of ugly there. This rectangle isn't in any particular spot on the ellipse. I'm just going to put a randomly placed rectangle. So let's just put a rectangle, say, about right here. Okay. So the corner of this rectangle is just some point x and some point y. So in other words, this distance is x and this distance is y. But I don't know what x and y are. What I want to find out is which particular x and y will give me the rectangle of maximum area. So I've done step 1. I've drawn the ellipse, I've inscribed the rectangle, and I've labeled the corner point in quadrant 1 x, y. Step 2 then is to write a formula for the area of the rectangle in terms of x and y. Well, we know the area of the rectangle is base times height. So the question is, how do the base and height relate to the x and y in this particular drawing? Well, the base would be this distance here. That would be 2 times the x distance. So we could say area is 2x, and then the height would be 2 times the y distance. So 2x times 2y, or 4xy. So area is equal to 4xy. Now when I maximize something, I want to have a function of area being just a function of x only. In other words, I want to substitute something for y that only has x in it. So when I do that, to do a substitution, I need another expression that relates x and y. This relates x and y to the rectangle and the area of the rectangle. But I have another way that x and y are related. X and y are both points on this ellipse. So I can solve the equation of this ellipse for y and substitute it into the area equation. So that's step 3. So I am going to write my equation here. X squared over 25 plus y squared over 9 equals 1. Now solving this for y, I would have y squared over 9 equals 1 minus x squared over 25. Multiply both sides by 9, and then take the square root of both sides. So y is the square root of the quantity 9 times 1 minus x squared over 25. Now, this would be plus or minus, but in this particular situation, I'm really not interested in a negative number for y. I just want to know y as a length of an area of a side of a rectangle. In other words, 2y is actually the height of the rectangle. I'm having trouble with that. So area is equal to 4xy, but y is equal to this expression of x. So I'm going to substitute all of that into the equation. So now I have this equation, area is equal to 4x times the square root of 9 times the quantity 1 minus x squared over 25. Now I want to find what is the maximum value of this area. In other words, what's the biggest area I can get with one of those x values. Now let's just remember here that x can only, if x goes between 0 and 5, somewhere in this quadrant, I'm going to get one particular rectangle that has the maximum area. So I'm only interested in values of x that are in between 0 and 5. So that's helpful to know. So what different areas can I get? Now what I'm going to do is graph this on the calculator. And in the calculator, I will be putting f of x equals 4x times the square root of 9 times 1 minus x squared over 25. And in the calculator, f of x will be my area. In other words, the y-coordinate will be the area, and the x-coordinate will be the x value of the point on the corner of that rectangle. Okay, so going to the calculator. So we open up a new graph window, and we're going to type in our equation, 4x times the square root of 9 times 1 minus x squared divided by 25. And we're going to graph this. Okay, we get this graph that goes down and comes back up and goes back down again. So what section of this graph am I particularly interested in? Well, I'm interested only in the section where x goes from 1 to 5, or from 0 to 5. I'm not really interested in the part where x is negative, and I also need to see the top of this graph, so I need to change some window settings. So I'm going to go to my window, zoom, window settings. I'm going to change my x to be from 0 to 5, and my y, I don't really need anything, I don't need y, negative values of y, because this represents area, remember. And then I need to get high enough up to see, and I'm just going to tell you 40 will do it. You sometimes have to do a little trial and error to figure out how high to go. I didn't probably need to go all the way to 40, but that's helpful. Now, I want to show you what what's actually going on here by looking at another part of this sketch here. Okay, so here I have two graphs together. So on the left I have my graph of my inscribed rectangle in this ellipse. Now what I have here is the graph that I just showed you, kind of a squished version of it, but notice if x is 0, the area is 0. And if x is 5, the area is 0. And somewhere in between, when x is around 3.5 something, the area is at a maximum. So it looks like the maximum is 30. So notice the 30 kind of stays there for a while for several values of x. That's because of some rounding issues we have here. But we're going to find exactly what value of x is going to give us that maximum value. So we're going to find the maximum point on the graph. So back to our scratch pad here. To find the maximum value of this graph, I'm going to go to Menu and Menu, Analyze Graph, and Maximum. Now this will give me a little dotted line. If you will swipe on your touchpad to the left until you get this dotted line to the left of the maximum point and push Enter, and then swipe it until it goes to the right and the maximum point shows up and push Enter, it will actually label this maximum point. Now I would like you to just make a little quick sketch of this graph and label that maximum point on your paper, and then let's talk about what that maximum point is telling us. So sketch the graph. Here we go, kind of looks like that. This is the point 3.5430. Now realize that this is the graph of where f of x represents the area and x is just the x coordinate on the corner of that rectangle. So this tells me when x equals 3.54, the maximum area is 30, and I'll say units squared. Okay, so when this is 3.54 units of length, whatever that length is, the maximum area is 30. So if I wanted to know the y value, I would look at one of my equations that has x and y in them. Well, I have two equations that have x and y. I have the ellipse equation and I have this little area equation, which would be much simpler to use in this case. So my area equation is area equals 4xy. So I can say that 30 is equal to 4 times 3.54 times y, and solving for y, I would get that y is 2.12. So that tells me that the point where the rectangle has maximum area is 3.54, 2.12. And I could also find the dimensions of the rectangle, because the dimensions would be 2 times 3.54 would be the base, and 2 times 2.12 would be the height. Now if we go back and look at the animation that we did here, if I can try to get this to be exactly at 3.54, it'll be a little tricky to get it there. Let's see if I can get it. 3.54. Ah, it's so hard. Okay, so let me just see if I can get it there. I don't know if I can do it. Okay, I don't think I can, but anyway, 3.54, 2.12 is the point I'm looking for, and that gives me that maximum value of 30. So I can't quite get it there, but that's what we just did. We maximized this area at that point with these dimensions, and this graph shows us that maximum area. In the next example, which will be the next video, I'm going to do then one dealing with volume.